Welcome everyone. Today we are going to make an introduction to friction. Whether you call it friction or frictional force, you are talking about the same thing. And if we should begin with the definition of friction, friction is defined as the force that resists the motion of an object over another object. So it is a force that opposes motion, okay? It is a force that acts parallel to a surface and opposes the motion of an object. It always acts in the opposite direction to the direction of the applied force, okay? So what we have to understand about friction is it is a force that opposes the motion of an object and it acts parallel to a surface. So because we said that it opposes the motion of an object, so if the object is moving towards the right, it means the frictional force is going to act towards the left. If the object is moving up an inclined plane, the frictional force is going to act down the inclined plane. If the object is moving down an inclined plane, it means the frictional force is going to act up the inclined plane. This is what we mean by it opposing the motion of an object. So moving on to the laws of friction. One of them is frictional force acts parallel to the surface in contact. Friction opposes the motion of an object over each other. Another law is frictional force has a maximum value of mu r. That maximum value of frictional force is what we call limiting equilibrium. Okay? Limiting equilibrium is a condition where the frictional force has reached its maximum value. That is, it can no longer increase. All right? We will come to that. Frictional force depends on the nature of the contact surface and not the surface area or the contact area. This is very important. So what does it mean by frictional force depends on the nature of the contact surface? It is referring to the roughness of the surface. The more rough the surface is, the more the frictional force, okay? But frictional force does not depend on the surface area. So it says kinetic or static friction is directly proportional to the normal reaction. This is very important, okay? We will discuss about this very soon. From the last law that we have stated here, it says the kinetic or static friction is directly proportional to the normal reaction. Okay, we will discuss all that later on. What is a kinetic friction? What is a static friction? So friction is represented with the letter F. So it says the frictional force is directly proportional to the normal reaction. Normal reaction is represented with the letter R. Okay, and I will discuss what the normal reaction means. For now, it is a force that is perpendicular to the surface and it presses the object on the surface. That is called the normal reaction. So if the frictional force is directly proportional to the normal reaction, it means that the more the frictional force, the more the normal reaction will increase. So if I want to remove this proportionality sign and replace it with a constant, that constant is what we call mu, or the coefficient of friction. So F is equal to mu r, okay, where the mu is called the coefficient of friction. So if I want to find mu, it means mu is equal to F all over r. We'll discuss that. So let's just move on. to some of these definitions. Let's try to define some of the terms here. We have static friction, we have dynamic friction, and we have limiting friction. Static friction is the frictional force that acts on a body at rest and prevents its motion. So when we talk about static friction, is the frictional force that acts on a body that is not moving. That is, the body is at rest, and the static friction prevents the motion of that body. But what if the body is already in motion? Again, it is subjected to a frictional force that we call dynamic or kinetic friction. So dynamic or kinetic friction is the frictional force that acts on a body in motion. And what does it do then? It resists the motion of the object. So even if the body is moving, it tries to resist its motion. It tries to show some opposition. That type of friction is what we call dynamic friction. Okay? Then we move on to another type of friction that we call limiting friction. So limiting friction is actually static friction, but it is when the static friction is maximum. Okay, so the static friction is maximum. That is, it means from that point the body will begin to start motion. It can no more prevent the motion of the object. What it can do henceforth is only to resist the motion of the object, to offer some resistance to the motion. That is what we call limiting friction. It's the maximum frictional force that must be overcome to just start the motion of an object that is initially at rest. It is simply the force that is required for the body to just start its motion. So the limiting friction is where the frictional force is maximum and the body is about to start motion. That is how we can define limiting friction. That brings us to a very important term called the limiting equilibrium. Limiting equilibrium is a condition when the frictional force is maximum and the body is about to move or slide. That is limiting equilibrium, where the frictional force is maximum and the body is about to move or slide. Okay? Now, what you have to understand is we have frictional force and we have pulling force. Usually these two forces are acting in opposite direction. So the more you pull an object along the surface, the more the frictional force will increase. So as you increase the pulling force, the frictional force also increases. But the frictional force cannot increase further after reaching a certain value. It has to reach a maximum value. All right? So that maximum value is a condition that we call limiting equilibrium, where the frictional force can no longer increase even if you increase the pulling force. So what happens? The pulling force is increased continually, but the frictional force has reached its maximum value. So it means what will happen? Motion will occur after that point. That is important to note. All right. Now we move on to define what we call normal reaction. Normal reaction is the force acting on the body that is perpendicular to the surface on which a body is kept. Roughly, if I have a diagram, let's say this is an object that is resting on a horizontal surface, the force that will come perpendicular, meaning 90 degrees to the surface, Okay, this is the surface. The force that will come 90 degrees to the surface is what we call the normal reaction. So we continue. It says if there is no other upward vertical force associated with the body resting on a horizontal surface, the normal reaction is equal to the weight of the object. So if this is the object, its weight is going to come vertically downwards. And from Newton's third law of motion, actions and reaction are equal and opposite. So which means R, which is the normal reaction, will be equal to the weight of the object, provided that there is no other vertical force that is associated with this object. If this object is on a horizontal surface, then the normal reaction will be equal to the weight of the object. So bear in mind that the normal reaction can also be called normal force, okay? They can also tell you the force that presses the object on the surface, okay? Is still the normal reaction or the normal force, okay? The normal reaction or the normal force is the normal contact force between the block and the surface. I want you to understand it that way. Moving on to another term is the coefficient of friction, otherwise called mu. This is a Greek symbol called mu, mu. All right. Now, what is the coefficient of friction? The coefficient of friction is defined as the ratio of the frictional force resisting the motion of two surfaces in contact to the normal reaction pressing the two surfaces together. The coefficient of friction shows the amount of friction that exists between the two contacting surfaces. That is the surface of the object and the surface on which the object is on or moving on. If the coefficient of friction is high, it means that the force required to move the object will be high. If the coefficient of friction is low, it means that the force required to move the object along the surface will also be low. So, by definition, coefficient of friction is equal to the frictional force divided by the normal reaction or the normal force. Okay, so coefficient of friction is mu. This is equal to frictional force is F divided by the normal reaction is R. So mu is equal to F over R. We have talked about the three types of frictional forces. We've talked about static friction. We've talked about dynamic or kinetic friction. And we've talked about limiting friction. So if they ask you the coefficient of static friction, then the frictional force has to be what? Static friction. So it's the ratio of the static friction to the normal reaction. If they ask you the coefficient of kinetic friction, is the ratio of the kinetic friction to the normal reaction. If they ask you the coefficient of limiting friction, is the ratio of the limiting friction to the normal reaction. That is the way you have to define it. So what is important to note is the coefficient of friction mu is equal to F all over R, where F is the frictional force, whether it is static friction, kinetic friction, or limiting friction. Okay, this is important to note.